Welcome everyone. In today's class, we are going to see about calcium and magnesium dynamics in soil. Calcium and magnesium both are positive ions. They are behaving almost similarly one another. The calcium is a very important plant nutrient and also an element deciding the conducive physical and chemical properties of soil. Means the calcium is involving in the aggregation process. Aggregated soil is good for agriculture practices so that if the calcium is present in the soil will get aggregated. At the same time, if there is sodium in the soil, it will disperse the soil particles, so it will make a problem to the soil. And in plant point of view, it is involving in cell wall protection, like it is present in the calcium pectate in the cell wall. So it is important for cell wall formation, cell elongation, and cell division. So these are all the important role the calcium is playing in the plant. So the calcium sources in soil. So they are mainly originated from rocks and minerals from which the soil was formed. So most important primary source is plagioclase mineral anorthite. Anorthite is a plagioclase mineral which having the formula of calcium aluminum silicate. Calcium, aluminum and silicate and oxygen are the component of this uh, anorthite. And basic rock, almost basic rocks like a pH higher and less silica content rock, they are having epidote, gabbro, basalt, diabase. They are the basic, they classified as basic rock. They and calcium carbonate, calcite, dolomite, calcium magnesium carbonate, calcium sulfate, gypsum. They are also the source of the calcium uh, to the soil. The calcium doesn't have any specialized fertilizer because they are present in the soil by applying incident fertilizer. Incident fertilizer, nothing but if we are applying any kind of fertilizer, if there is any calcium or magnesium as a composition, that calcium magnesium will be added to the soil, like single superphosphate. Mainly we are using it for phosphorus source, but it is also contain uh, calcium. So this calcium will be added to the soil. And biotite, apatite, borosilicate, and other simple salt also contribute for the calcium. Apart from that, we are adding some fertilizers like fertilizer and soil conditioner like gypsum, calcium carbonate, that is lime. From that, the calcium and calcium can be added. If you are adding dolomite, calcium magnesium carbonate, or sometimes calcium magnesium sulfate, that will add both calcium and magnesium to the soil, and manures also contributing calcium to the soil. So you can see the simple representation of calcium and magnesium equilibrium and transformation in soil. Here the soil solution is the major form where the plant can be receiving the soil, plant can be received the calcium. Okay, that is called uptake. Soil solution means calcium and magnesium both will be dissolved in the soil water and they can be uptake by the plants. So both are having calcium and magnesium having a same representation because they are similar ions behaving similarly. Manures, some organic manures we are adding from that source. The calcium and magnesium is being added to the soil. Apart from that, I said incidentally they are applying, like when you are applying lime, not lime, calcium magnesium carbonate, dolomite, and Epsom, calcium magnesium sulfate, Epsom. They are also providing calcium and magnesium. Here you can see some other form. This is exchangeable calcium and magnesium. They are absorbed by the soil particle, calcium and magnesium. That anytime it can move to the soil solution, they are having rapid equilibrium between this. At the same time, the mineral, they are also having some calcium, which is also having equilibrium with the soil solution, but this equilibrium is very slowest. When the calcium containing parent material present in the soil, that will supply the calcium to the soil solution. But here exchangeable calcium and magnesium, here also having a good rapport that ca calcium will be getting equilibrium between these two, exchangeable and magnesium, mineral calcium. So these exchangeable and solution forms are in dynamic equilibrium. These two, exchangeable and solution, are dynamic equilibrium. The solution calcium subjected to crop removal and leaching. So the solution calcium, I am telling that the plant can be uptaken through this form. At the same time, the leaching also will happen when the excess rainfall is happen, or any other forms of calcium removal can be taken along with the irrigation water or rainwater. That process is called leaching. Coming to factors influencing calcium availability. So it is depending on various factors. One is total calcium supply. Soil that have lowest cation exchange capacity, typically low in calcium. So the exchange sites mostly occupied by the calcium. Calcium is the dominant ion, first one, and the second one is magnesium, third one is potassium, and fourth one is sodium. This is the order of the amount of nutrient present in the soil. So when the calcium amount is lowest in the exchange sites, the calcium availability also get reduced. But calcareous and black soils, they are rich amount of calcium. They are having rich amount of calcium. Calcareous soil, because this is calcium rich soil, and black soil. Black soil naturally having more calcium because they are having more amount of clay. Clay having negative charge. Due to that negative charge, easily the positive charge can be absorbed through the isomorphous substitution. And alluvial and acid soil are deficient. Alluvial soil and acid soil. Acid soil generally having a lowest amount of calcium. When the pH is getting reduced, the calcium, magnesium, sodium, this kind of salt availability also getting reduced. The salt availability only present in a higher amount in pH more than 7.5. So you can see the pH also. So as I told, the acidic soil having low in calcium due to high aluminum saturation. This aluminum can be held in the exchange sites, like in the clay material, because it is negative charge. The aluminum is a positive charge and a high valency ion Al3 plus. This Al3 plus can be held in the surfaces of soil, followed by calcium, followed by magnesium. So the first priority will be given to the aluminum, but the lowest valency, that is calcium, can replace aluminum. This process is called isomorphous substitution. Calcium is a lower valency, that is Ca2 plus, Al3 plus. Aluminum is having 3 valency. So the lower valency ion replacing the higher valency ion in the exchange sites is called isomorphous substitution. When it is happen, when this process is taking place, there it will leave one net negative charge, Okay, this is what the isomorphous substitution is happen. And normally in acid soil, hydrogen ion activity is very high. This hydrogen ion is hinders the availability of calcium in soil. High in neutral and alkaline pH. So having said it, the availability will be increasing when the pH level also increasing in the soil. Third one is type of soil. The availability also depends on the type of soil. Like moderately weathered soil have greater amount of available calcium. Moderately weathered soil such as alphisol, inceptisol, vertisol, they are moderately weathered soil compared to highly weathered soil. Highly weathered soil or altisol, oxisols. From the soil, the calcium would have been disappeared, but the moderately weathered soil is holding more amount of calcium rather than highly weathered soil. And type of clay also influences, whether it is kyolinate clay or montmorillonate clay or chloride clay. So this kind of clay also affecting the availability of calcium. And 2:1 require high calcium saturation. The 2:1 nothing but expanding type of clay mineral. It needs 70% of saturation. But 1:1 require low. Then only the cation exchange capacity will be good. Okay. And cation exchange capacity contains less than 25% of calcium will be a problematic one in the availability of calcium. So in this condition, you must apply the calcium in any form to the soil. So black soil having highest CEC, that's what I am telling, that clay influences the availability. Black soil generally having more amount of clay. So if since it is having a high negative charges, it can easily hold the positive charges such as calcium. And the red soil has low CEC. Red soil has lowest amount of clay when compared with the black soil, so that this is also having lower availability. So black soil has more availability, red soil has low availability of calcium. Percent calcium saturation. It is directly proportional to calcium availability. Means how much amount of calcium is saturated when compared with the other elements such as calcium, magnesium, sodium, potassium, and aluminum, iron, everything, how much they are present in the soil, what is the ratio of calcium in that. It is also depends on, this is also decides the calcium availability. Poor base saturation exhibit deficiency. Base saturation should be very high for the soil, then only the cation exchange capacity will happen very smoothly. So below 40 to 60% reduce the yield of cotton. So it must be more than 70 to 80%, more than 70 to 80%. If not, it will reduce the yield. Here in cotton alone, 40 to 60% of calcium should be saturated in the percentage of base saturation. 20% or less reduce the yield of soybean. So 20% or less, it directly influence the yield of soybean. Okay, so we have to maintain a proper amount of calcium in the soil. Ratio of calcium to other cation in solution. Ratio, how much ratio it should be there in other. So the same way what we have discussed, this is 0.6 to 0.8 percentage, means 60 to 85% of calcium alone should be present there when compared to other ions like magnesium, potassium, and sodium. Okay, so 60 to 85% means remaining at least 10% of magnesium should be there, and 2 to 5% of potassium, and the remaining sodium. This is the order of amount of availability, amount of ratio of calcium should be there. And calcium uptake diffused by other cations such as ammonium, potassium, magnesium, manganese, aluminum. All cations will influence the availability of calcium in a negative way. So absorption increase with supply of nitrate nitrogen, because it is having a negative charge. When the nitrate nitrogen is present a higher amount in the root zone, it will having affinity. It will have affinity with calcium, so that calcium uptake also increasing. Here it is a losses of calcium. Normally leaching is high, especially in the high rainfall zone. All the cations will be washed away. Highland soil having salinity due to calcium magnesium with sulfate and the chlorides. Nothing but calcium sulfate and the calcium chloride. So they are rich in the lower plain areas, because in a higher elevated area, all the cations will be washed away, and it will be settled in the lowest plain areas, where you can find out all kind of salt material like calcium, magnesium, sodium, potassium. When they are combining with sulfate and chlorides, definitely it will produce a salinity. Okay, so 200 to 500 pounds of calcium is leached through drainage water per hectare per year. Per hectare per year means nearly 100 to 250 kg. 250 kg of calcium and magnesium is leached every year per hectare alone. So this is magnesium. Magnesium is a primary constituent of chlorophyll along with the nitrogen. It is also taking part because magnesium is a central atom of chlorophyll molecule. Okay, it is very important to maintain the magnesium content in the plant so that the soil should apply a proper amount of magnesium. So 15 to 20 percentage of total magnesium is involving in chlorophyll formation. So ATP, adenosine triphosphate, also requires magnesium for their activity. So it is this magnesium mainly involving in synthesis of fats and oil. Sources originate from weathering of rocks. So rock is the main source. I already told that it is applying added to the soil incidentally. Some primary minerals, secondary minerals also supplying magnesium, especially dolomite, biotite, olivine, and secondary minerals. If you see illite, montmorillonite, and vermiculite, they are containing magnesium. And some amount of magnesium is supplied by epsomite, that is magnesium sulfate, and bloodite, sodium magnesium sulfate. So along with sodium ion, magnesium ion also combined here. So it is supplied in the form of sulfate so that they are providing magnesium. And as like calcium, manures and fertilizer also added. Fixation. Magnesium replaces aluminum in 2:1 type of clay rather than calcium. The magnesium is involving in the isomorphic replacement. So it can replace the higher valence ion, that is Al3. Okay. Chlorite and vermiculite have greater amount of magnesium because chlorite is a 2:1 type of clay mineral. In this 2:1 type of clay mineral, the middle layer is called brucite. Brucite is rich in magnesium. So the magnesium is high in the fluorite containing minerals, as well as the vermiculite. This is also having substantial amount of magnesium. So they are supplying magnesium to the soil. Here you can see how much amount of magnesium is present contributed in each mineral. Chlorite, as I said, the brucite layer, because of that it has 23%, and vermiculite 12 to 15%, biotite 7%, muscovite and montmorillonite 6%, and illite very lowest amount, that is 1% of magnesium it is supplying. Like calcium, magnesium also getting lost. Actually amount is 12.5 to 150 pounds, like almost 5 to 70 kg of uh, magnesium getting leached every year from 1 hectare of land. Severe in sandy soil. The sandy soil, the water holding capacity, nutrient holding capacity is very lowest, so that the highest leaching amount of leaching will be happen in the sandy soil rather than the clay soil. When you are applying muriate of potash and sulfate of potash to the soil, the uh, uh, nutrient losses will happen. Okay. So leaching is next to calcium but greater than potassium. The first one is calcium, second one is magnesium, followed by potassium. This is the order of leaching is taking place. There are some factors influencing the availability of magnesium. Soil type. So as we have seen in the calcium, the same way, when the soil containing rich amount of magnesium, the magnesium availability is very high. So inherently low in magnesium containing mineral. Magnesium containing mineral. So naturally they are having very lowest amount of magnesium, so that availability also getting reduced. In acidic condition, as well as the light texture soil, nothing but sandy soil, they are rich in potassium, not magnesium. So here the magnesium availability is reducing. Amount of exchangeable magnesium. How much amount of magnesium is exchanging in the exchange site? Like the optimum range is at least it should be 100 to 300 ppm. must be present in the soil. If it is reducing less than 100 ppm, it will definitely show the deficiency in all kind of plant. And highly leached magnesium definitely will lead to lesser availability because the magnesium won't be there in the soil system. And when we are planning for liming, preferably we have to apply a calcium magnesium carbonate, that is called dolomite, instead of applying lime alone. Calcium carbonate alone, calcium magnesium carbonate, if we are using the calcium carbonate, will increase the pH. At the same time, magnesium will be added to the soil. Ratio with other ion. Excessive amount of other cations compete with magnesium and reduces at cation exchange sites. So we have seen the ratio of magnesium is compete with other amount of other elements, so that this magnesium having a competition with some other elements. So because of that, the magnesium availability also reducing. The calcium magnesium ratio greater than 10:1 to 15:1, definitely it will lead to the deficiency of magnesium in soil. The optimum calcium magnesium ratio is 3:1 is 3:1 to 7:1. In this ratio, if calcium magnesium are maintaining, definitely the availability of magnesium would be taking place. But when it is the calcium ratio, calcium part is increasing, the magnesium will get suppressed. Okay, so that availability is reducing. So and other element, that is potassium, this is also compete with magnesium. When potassium magnesium ratio should be less than 5:1 for field crops, 3:1 for vegetable, and 2:1 for fodder crops. Okay, this is what the ratio should be there. And finally, ammonia-induced magnesium stress also reported in soil of low magnesium. Sometimes the ammonium is competing with magnesium, so that magnesium stress will happen in the soil. Thank you for attending the class.